clear from my side, Sahil? Oh, sorry. Okay, so sorry for that. Actually, my mic is muted, right? Anyway, we'll start with initial again. No problem. Sahil, now it is audible.
Yes, sir.
Okay, thank you. So, welcome to AICTE sponsor Prerana Center for SC/ST students at Vidya Pratishthan Kavalna Bajaj Institute of Engineering and Technology, Baramati. Here in these sessions, we are going to discuss about the operation research topic as per as your GATE 2022 concern. So, in these topics, we are going to see the CPM and PERT problems, right? What is in by CPM and PERT? This is session number 1 on this. Okay. So before starting the project management or CPM PERT, let us see about which types of questions may be asked in the GATE, right? In the past previous papers, we'll see, just take an overview on that. So if you see the last year paper, there is a question number 35 will be on the your PERT problem, right? That is from the PERT technique. So here you can see that question, that is activity A, B, C and D are from the critical path for a project with a PERT network. The means and variance of the activity durations for each activity are given below. All the activity durations follow the Gaussian distribution and are independent of each other. So you can see that activity A, B, C, D are there. Its mean and variance are given, that is 6, 11, 8, 15 are means are given respectively for A, B, C, D, and the variance are 4, 9, 4, 9 like that. So from this data you need to calculate the probability that the project will be completed within the 40 days, right? So as you know that the probability is just a number which is ranging between 0 to 1, right? So just you have to calculate that the probability of this project will complete within 40 days. This is problem of the PERT, right? And in last that means in the another paper, that is in GATE 2019, question will be asked for again 2 marks. A project consists of 6 activities, that is the immediate predecessors of each activity, and the estimated duration is also provided in the table. So you can see the activity, immediate predecessors and estimated durations are there. So if all the activities other than S take the estimated amount of time, the maximum duration of activity yes without delaying the completion of project you have to calculate, right? So these types of question may be asked in the GATE exam, right? You can see the all the previous years question papers, you'll see these types of questions on the CPM and PERT, right? This will carry the weightage of 2 marks, and these are very simple and you can easily find out the answers, right? And you can within a short interval of time, and you can solve this, you can take these 2 marks. Okay, so before solving these numericals, before seeing the numericals from the CPM and PERT, let us see the first theoretical concept of the project management. What is meant by project, what is meant by project management, and the CPM and PERT. Okay, so let us start with the introductory part of the project management. So a project is a series of tasks that need to be completed in order to reach a specific outcome. All of you know that what is meant by project, right? As you are doing the mini projects, you are doing the your last year projects also, right? So project is a series of tasks that need to be completed in order to reach a specific outcome. That means whatever you are doing the projects in your final year or mini projects, you are dividing that projects into a sub task, right? Or the, we can say, sub activities, and you are doing that activities within a given period of time, right? So that is what the project part, right? That means the tasks we are trying to complete within a given period of time, that will complete that will achieve your project. Okay, so a project can also be defined as the set of inputs and outputs required to achieve a particular goal also, right? So that means in case of project, you need to provide some inputs, right? And from that you need to take some outputs also, right? So that means for a project you need to provide an input, and from that you will get the output also. So what is scheduling in the project, right? Because the project is a series of tasks, and all the tasks we need to complete within a given period of time. So that's why we need to schedule the something right in the project, right? Or the tasks are there in there. So scheduling is just an laying out the actual activities of the project in time order in which they are to be performed, and calculating the manpower and material requirements needed at each stage of production. So along with expected completion of time of each of activity, right? So it is intended to match the resources of equipments, materials, and the labor with a project work tasks over the time. So system, that is activity on arrow time, that is one of the part in the project system. So an activity is graphically represented by an arrow. The tail end and head end of arrow represents the start and finish of an activity respectively. So project management is evolved to coordinate and control all the project activities in an efficient and cost effective manner. The silent features of a project are, you can say, a project has identifiable beginning and end points. Each project can be broken down into a number of identifiable activities which will consume time and other resources during their completion. Right. Whatever you are deciding the project, just we are taking the example of your final year project, right? So you are deciding some projects, right, to do for your the final year engineering, right? So you know that there should be some beginning, there should be some start point, and there should be some end point. So you are starting with a start point and you are trying to reach to the end point, right? So that in that there are certain number of tasks are there and you are trying to complete that task, right? And so that you will try to find out the output for each task, and you are in the you are in the search of the final results, right? At the end, that means it is expected that at the end points you will find out some conclusion from the all the tasks, right? So that is the project has some identifiable, we can say, beginnings, and it has some end points also, right? So each project can broken down into a number of identifiable activities which will consume some time and other resources during their completion. So in your project work you are trying to break down this project work into a number of activities, so that it will consume some time, right? It will consume some resources in terms of monies, in terms of we can say time, right, in terms of some input parameters, and from that we'll get some output also, right? So a project is scheduled to be completed by target date also, right? So we are trying to schedule the project and by and we are trying to complete it by target date. A project is usually large and complex and has many interrelated activities also, right? Your project should be usually very large and it should be very complex and has many interrelated activities are also there, right? So this is about the some silent features of the projects, right? Okay, then let us see what is in by the project management. So project management is the application of processes, methods, skills, knowledge, and experience to achieve the specific project objectives. According to the project acceptance criteria within the agreed parameters, project management has final deliverables that are constraints to a finite time scales and budget also, right? So this is what about the project management. Then project management generally consists of three phases, that is planning, then we can say scheduling, and then controlling. So let us see what is in by planning. So planning involves setting the objectives of a project, identifying the various activities to be performed, and determining the requirement of resources such as men, materials, machines, etc. The cost and time for all the activities are estimated, and a network diagram is developed showing sequential interrelationships between the various activities during the planning stage. Scheduling is based on the time estimates. The start and finish times for each activity are worked out by applying forward and backward pass techniques. Critical path is identified along with the slack and float for the non-critical paths. And last is controlling. Means what? Controlling refers to analyzing, evaluating the actual progress against the plan, and reallocations of resources, crashing and review of projects with periodical reports are carried out in the controlling stage. So these are the basically three phases of the project management, and we have to work on that during your throughout the project, right? Initially you have to do the planning, you have to do the scheduling, and you have to control the project also during its working stages, right? So that all the things will goes very good, right, in the well manner, right? And you will get the win-win situation, right, if all the things are going well. Then let us see the network construction. In the project we know need to develop some networks, right? That is, we need to develop the network. That's why we require the network construction. A network is the graphical representation of the project activities arranged in a logical sequence. we are taking the project, we are dividing that project into sub activities, and now we have to relate all these activities with the help of some graphical meaning, right? That is nothing but what your network. So network is a graphical representation of project activities arranged in a logical sequence and depicting all the interrelationships among them. A network consists of activities and events. So as this is a graphical representations of the project activities, it consists of some activities and events occurring in that. Okay, so let us see what is meant by activity first. An activity is a physically identifiable part of a project which consumes both time and resources. Activity is represented by an arrow in a network diagram. The head of an arrow represents the start of activity and the tail of arrow represents its end. Okay, so in that one of the type of activity is dummy activity. So let us see what is meant by dummy activity. An activity which is used to maintain the predefined precedence relationship only during the construction of the project network is called as dummy activity. Dummy activity is represented by dotted arrows and does not consume any time or resources, right? We will see that in detail in the when we are drawing the network constructions, right? Network drawings. Let us see what is in my event now, right? So an event represents the accomplishment of some task in a network diagram. Beginning and ending of an activity are represented as events. Each event is represented as a node in a network diagram. An event does not consume any time or the resources. Each network diagram starts with initial event and end at its terminal event, right? So you can see here in the bottom one diagram, just one arrow representation is shown just for which is used in the network diagram. Actually, you can see that I and J are the event. That is, I is called as tail event and J is called as an head event. You can see because the arrow is moving from left to right, so arrow is going towards the J. So that's why J is called as an head event and I is your trailing event. So that's why it is called as an tail event. On that when we are doing the event that is moving from I to J, right? We are doing some activity, right? So that activity is shown on that arrow, right? So generally events and activities are represented like this in the network diagram. There is some rule for drawing the network diagrams, right? So let us see that the Fulkerson rules. So each node is represented by a circle and number by using the Fulkerson rule. So how to represent that? Let us see. The following steps are involved in the numbering of the nodes also. So that is, first is the initial event which has all the outgoing arrows and no incoming arrow is numbered as a 1. That means first event from which all the arrows are going, right? That means all it has all outgoing arrows, there is no incoming arrows to that event. We are numbering that event as a 1. Okay, remember that. Then delete all the arrows coming out from the node, just number that is only 1. So this tip will create some more nodes into initial event. Number these events in ascending orders like 2, 3. Okay, that is second step. Then third step will continue the process until the final or terminal node which has all arrows coming in with we can say with no arrow going out is number as a, we can say, sequentially. This is for the numbering, that is Fulkerson rule is for the numbering the we can say events. And rules for drawing the network diagrams are as follows. That is, first, each activity is represented by one and only one arrow in a network diagram. Then second rule is that no two activities can be identified by the same end events. That means for two activities there should not be any same end events. Then third, precedence relationship among all the activities must always be maintained, and dummy activities can be used to maintain precedence relationship only when actually required. Their use should be minimized in the network diagram also. The next is that looping amongst the activities must be avoided. That is rule number 5. Okay, so these are the actually rules for drawing the network diagram. We will see that with the help of more images in the next slides. Okay, so actually here you can see the one network diagram is given. Actually here the activities A, B, C, D, E are doing on the events. You can see in the project actually here in the top one figure you can see that this one is given as wrong, here it will given as right. So anyone can me just tell me why the first network diagram is wrong and second one is the correct one? Any error here it is observable for you?
The arrow must be forwarded. One arrow, first diagram is backward for C.
Yes, who is there? I think Sahil.
Aditya Power.
Aditya, okay, correct. Thank you. You can see that here in the first diagram the arrow is moving from right to left. Is it right? In the first diagram, okay, for the C. But here in the second diagram the arrow is moving from left to right. You see that the arrows should be moving from left to right. That means all the arrows in the preceding direction. There is no any arrow in the reverse direction in the network diagram, right? So this is what actually the looping error. We will see that in the next slide in detail what is in by looping error. So that's why this network diagram is wrong. Here you can see this is the correct one, right? So correct answer given by the Aditya. आवाज पण येतोय माझा, ठीक आहे. So this is what the you can say right and wrong, these are the two network diagrams, right? So you can identify which one is right and which one is wrong, right? There should not be a looping error, right? Like this. So that's why the bottom one is the correct. Now let us see about the some network techniques, right? What are the network techniques and what are the different methodologies for it? So there are two popular tools used for analysis of network diagram. Now I think all of you are must clear about this. What is in by network diagram, right? A network diagram is what? It is just an diagram which is used for interrelating, which will shows a graphical representation of your project activities, right? As all of you know that the what is in by project and the project activities, because what we are taking one project, we are dividing that project into a sub activities, right? And now we have to show that interrelation between that activities with the help of some graphical method. That is nothing but what? It is a your network diagram, right? So for analyzing this network diagram, right, for analysis of this network diagram there are different techniques are there. So what are that network techniques? That is, first is a CPM, that is critical path method, and second one is a program evaluation review technique, that is PERT. Whatever we are going to see in today's session, right? That means our aim is to study this CPM and PERT techniques, right? Okay, so let us see what is in by critical path method. So actually let us see about the some history of it, right? So actually it was developed in 1956 1957 by Remington Rand and DuPont to help schedule maintenance projects in chemical plants and construction projects. Critical path method is a systematic scientific method based on principles of time estimates to perform a detailed analysis of network in an application of project management. So the CPM, that is critical path method system of networking, is used when the activity time estimates are deterministic in nature. For each activity a single value of time required for its execution is estimated. The time estimates can easily be converted into a cost data in this technique, and CPM is an activity oriented technique, remember that, right? So CPM, when we can go for the CPM, that is critical path method, where when the activity time estimates are deterministic in nature, that means it is possible for us to calculate the activity time estimation, right? Then let us see what is by PERT, right? So that is a program evaluation review technique, right? So it's just a short form of program evaluation review technique is PERT, right? So PERT chart is a tool used to schedule, organize and coordinate tasks within a project, right? With the help of PERT technique you can schedule, you can organize and you can coordinate the tasks what are there in the project. It was developed by US Navy in 1950s to manage the Polaris submarine missile programs. Okay. So let us see just overview on this difference between the CPM and PERT. What is the major difference between these two, right? Comparative study in this slide. So CPM is an activity oriented, where the PERT is an event oriented technique. Then the time estimates are of fair degree of accuracy in CPM, whereas in PERT the time estimates are not that accurate. CPM is a deterministic approach, whereas the PERT is probabilistic approach, right? As earlier in the first slide we have seen that the problems from the PERT, right? It is in that problem there will be the findings are that you need to find out the probability that the project will be completed within 40 days. That's why we are calling it as a probabilistic approach, right? So then next, cost is governing factor in CPM, whereas in PERT the time is governing factor. Then project duration is fixed and cost is minimum in CPM, whereas cost is directly proportional to the time in case of PERT. CPM is a critical path which joins critical activities, whereas PERT is we can say critical path is a path which joins the critical events here in the PERT, right? So this is what the difference between the CPM and PERT. Okay. So is it the voice is clear from my side? Is it the screen is visible? Someone just unmute and tell me.
Yes, sir.
Okay, thank you. Are you getting all these things?
Yes, sir.
Okay, thank you. So let us see the components of PERT and CPM network. So PERT CPM networks contains two major components. That is, first is activities and second will be the events. Okay. So what is activity? An activity represents an action and consumption of resources, time, money, energy required to complete a portion of project. Activity is represented by an arrow, right? You can see that the arrow here you can see activity that is I to J, that means the events I and J are there, and activities performed during this event, right? That is A activity. A is called as an activity in this diagram, whereas event is what? An event will always occur at the beginning and end of the activity, right? So the event has no resources and is represented by a circle only. The ith event and jth event are the tail and head event respectively. This ith is called as a tail event and this j is called as an head event because arrow is towards the j, so that's why it is called as an head event. Remember that. So these are the two terms in the event, head and tail event. Okay. So here also in the bottom one figure you can see that for an event. Then next, let us see merge and burst of event. What is meant by merging and bursting of event? So one or more activities can start and end simultaneously at event. Here you can see that this is what again event. So here you can see three activities. The arrow means what? It is an activity, right? So three activities are merging to the single event, you can see. So that's why here it is called as a merge of event. Here from this you can see from one event three activities are outgoing. That means this is bursting of event, like that. Okay. So this position we are this type of symbol if you observe in the network diagram, you can say here the merging of the event will take place, here the bursting of the event will take place, right? Basically this you may observe in the end of the event and this will observe at the start of the event, right? Okay. Then preceding and succeeding activities, these are the again very important terms. As earlier we have seen one or two problems from the gate point of view. So you have seen that there are terms like preceders, succeeders, activities. So let us say what is meant by preceding activity, what is meant by succeeding activity. So activities performed before given event are known as preceding activities, right? The activities which perform before a given event are called as an preceding activities, and the activities performed after given event are called as an succeeding activities, right? So here you can see the activities are given like I, J, K, and you can see here L, like that. Okay, I, J, K, L. Okay, these are the events, and the activities like A, B, C, D are given, you can see here. So let us see what is meant by preceding and succeeding activity, right? So activities A and B, that means this activity A and B is called as preceding activity of C and D. This is called as A and B is called as preceding activity of C and D because A and B are precedes of C and D. Whereas, right, you can see that C and D activities are called as succeeding activity of A and B because C and D activities are beyond your A and B activity, right? These are after your A and B activity. So that's why we are calling as C and D activity are called as succeeding activity of A and B, like that. Is it clear for all what is meant by preceding activity and what is meant by succeeding activity? You can call activity B is a preceding activity of D here also. Okay, whereas activity D is succeeding activity of B. Same as for A is preceding activity of C, whereas C is succeeding activity of A. Have you got all of you? Yes or no? What is meant by preceding and succeeding activities? Have you got these things? What is meant by preceding and succeeding activities?
Yes, sir.
Okay, thank you. Then let us see dummy activity, right? So what is meant by dummy activity? Let us see. It is an imaginary activity which does not consume any resources, time, and time is called as a dummy activity, right? So activities are simply used to represent connection between we can say events in order to maintain a logic in the network. So it is represented by a dotted line in a network. Okay, so here you can see that the dummy activity, these are the activities A, B, C, and this is dummy activity shown with the help of the, you can say, just a dotted line, right? So it does not consume any resource or it does not consume any time also, right? So that is your dummy activity. So here you can see that where we can use this dummy activity, right? So here some examples are given. That means these are actually errors to be avoided in constructing the network diagram, right? When you are going to construct a network diagram, you should take care of this. You should avoid these errors, right? So first is what? The two activities starting from tail event must not have same end event. That means the two activities are starting from a single tail event should not be end at the single that means same end event, right? So to ensure this, it should be absolutely necessary to introduce a dummy activity in that case. Here you can see in the first figure, right? 1 and 2, these are the two events, and from this one two activities are we can say uh, bursting, right? That means two activities are going like this one and this, but these two activities again ending at same event, that is number 2, right? So we can say that two activities starting from tail event must not have same end event, right? It should be for this activity there will be other end event, it should be for the second activity there another event, right? But if they are coming to the again same event, then this will be not the correct network diagram, right? So for that you can provide the one dummy event in that, right? So dummy activity, actually here you can see dummy activity like this. Okay, the next the looping error should not be formed in a network at it represent the performance of activities repeatedly in a cyclic manner as shown in figure. So the looping error should not be there like this, that is 1 2 3 again 1, this cycle, right? In the network diagram, just we have seen in the previous 3 to 4 slides before that we have seen one the correct and incorrect network diagram, right? So remember that always arrows moves from left to right only, not from the right to left, right? In the backward direction, always arrows moves from left to right, that is in forward direction only in the network diagram. Otherwise it will create a looping error, right? Then next, in network there should be only one start event and one ending event as shown in figure. So you can see that there here you can see these are the two events, right? So these are not again same, right? Only one start event and only one end event should be there, right? Okay, the next, the direction of arrow should be flow from left to right, avoiding mixing of direction as shown in figure. Okay, so this is the arrows moving from left to right like this. Okay, it should not be moved from we can say right to left, that is it will form a wrong direction of arrow, it will form a looping error. Okay, so these are the some errors to be avoided during the constructing network diagram. Rules in constructing networks, that is first, no single activity can be represented more than once in a network, right? Then the length of an arrow has no significance, you can draw any size of length of arrow. Then the event number 1 is the start event, and event with highest number is the end event in the network diagram, right? Before an activity can be undertaken, all the activities preceding it must be completed, that is the activity must follow a logical sequence between the activities. Then third, in assigning numbers to events, there should not be any duplication of event numbers in a network. Fourth, dummy activities must be used only if it is necessary to reduce the complexity of network. The next, a network should have only one start event and only one end event. So these are the some rules to be. आवाज पण येतोय माझा ठीक आहे. So this is what the you can say right and wrong, these are the two network diagrams, right? So you can identify which one is right and which one is wrong, right? There should not be a looping error, right? Like this. So that's why the bottom one is the correct. Now let us see about the some network techniques, right? What are the network techniques and what are the different methodologies for it? So there are two popular tools used for analysis of network diagram. Now I think all of you are must clear about this. What is it by network diagram, right? A network diagram is what? It is just an diagram which is used for interrelating, which will shows a graphical representation of your project activities, right? As all of you know that the what is by project and the project activities, because what we are taking one project, we are dividing that project into a sub activities, right? And now we have to show that interrelation between that activities with the help of some graphical method. That is nothing but what? It is a your network diagram, right? So for analyzing this network diagram, right, for analysis of this network diagram, there are different techniques are there. So what are that network techniques? That is, first is a CPM, that is critical path method, and second one is a program evaluation review technique, that is PERT. Whatever we are going to see in today's session, right? That means our aim is to study this CPM and PERT techniques, right? Okay, so let us see what is meant by critical path method. So actually let us see about the some history of it, right? So actually it was developed in 1956 1957 by Remington Rand and DuPont to help schedule maintenance projects in chemical plants and construction projects. Critical path method is a systematic scientific method based on principles of time estimates to perform a detailed analysis of network in an application of project management. So the CPM, that is critical path method system of networking, is used when the activity time estimates are deterministic in nature. For each activity, a single value of time required for its execution is estimated. The time estimates can easily be converted into a cost data in this technique, and CPM is an activity oriented technique, remember that, right? So CPM, when we can go for the CPM, that is critical path method, where when the activity time estimates are deterministic in nature, that means it is possible for us to calculate the activity time estimation, right? Then let us see what is by PERT, right? So that is a program evaluation review technique, right? So it's just a short form of program evaluation review technique is PERT, right? So PERT chart is a tool used to schedule, organize and coordinate tasks within a project, right? With the help of PERT technique, you can schedule, you can organize and you can coordinate the tasks what are there in the project. It was developed by US Navy in 1950s to manage the Polaris submarine missile programs. Okay. So let us see just overview on this difference between the CPM and PERT. What is the major difference between these two, right? Comparative study in this slide. So CPM is an activity oriented, where the PERT is an event oriented technique. Then the time estimates are of fair degree of accuracy in CPM, whereas in PERT the time estimates are not that accurate. CPM is a deterministic approach, whereas the PERT is probabilistic approach, right? As earlier in the first slide we have seen that the problems from the PERT, right? It is in that problem there will be the findings are that you need to find out the probability that the project will be completed within 40 days. That's why we are calling it as a probabilistic approach, right? So then next, cost is governing factor in CPM, whereas in PERT the time is governing factor. Then project duration is fixed and cost is minimum in CPM, whereas cost is directly proportional to the time in case of PERT. CPM is a critical path which joins critical activities, whereas PERT is we can say critical path is a path which joins the critical events here in the PERT, right? So this is what the difference between the CPM and PERT. Okay, so is it the voice is clear from my side? Is it the screen is visible? Someone just unmute and tell me.
Yes, sir.
Okay, thank you. Are you getting all these things?
Yes, sir.
Okay, thank you. So let us see the components of PERT and CPM network. So PERT CPM networks contains two major components. That is, first is activities and second will be the events. Okay, so what is activity? An activity represents an action and consumption of resources, time, money, energy required to complete a portion of project. Activity is represented by an arrow, right? You can see that the arrow here. You can see activity, that is I to J, that means the events I and J are there, and activity is performed during this event, right? That is A activity. A is called as an activity in this diagram, whereas event is what? An event will always occur at the beginning and end of the activity, right? So the event has no resources and is represented by a circle only. The ith event and jth event are the tail and head event respectively. This ith is called as a tail event, and this j is called as a head event because arrow is towards the j, so that's why it is called as a head event. Remember that. So these are the two terms in the event, head and tail event. Okay, so here also in the bottom one figure you can see that for an event. Then next, let us see merge and burst of event. What is meant by merging and bursting of event? So one or more activities can start and end simultaneously at event. Here you can see that this is what, again, event. So here you can see three activities. The arrow means what? It is an activity, right? So three activities are merging to the single event, you can see. So that's why here it is called as a merge of event. Here from this you can see from one event three activities are outgoing. That means this is bursting of event, like that. Okay, so this position we are this type of symbol, if you observe in the network diagram, you can say here the merging of the event will take place, here the bursting of the event will take place, right? Basically this you may observe in the end of the event, and this will observe at the start of the event, right? Okay, then preceding and succeeding activities, these are the again very important terms. As earlier we have seen one or two problems from the gate point of view. So you have seen that there are terms like preceders, succeeders, activities. So let us say what is meant by preceding activity, what is meant by succeeding activity. So activities performed before given event are known as preceding activities, right? The activities which perform before a given event are called as an preceding activities, and the activities performed after given event are called as an succeeding activities, right? So here you can see the activities are given like I, J, K, and you can see here L, like that. Okay, I, J, K, L. Okay, these are the events, and the activities like A, B, C, D are given, you can see here. So let us see what is meant by preceding and succeeding activity, right? So activities A and B, that means this activity A and B is called as preceding activity of C and D. This is called as A and B is called as preceding activity of C and D, because A and B are precedes of C and D. Whereas, right, you can see that C and D activities are called as succeeding activity of A and B, because C and D activities are beyond your A and B activity, right? These are after your A and B activity. So that's why we are calling as C and D activity are called as succeeding activity of A and B, like that. Is it clear for all what is in by preceding activity and what is in by succeeding activity? You can call activity B is a preceding activity of D here also. Okay, whereas activity D is succeeding activity of B. Same as for A is preceding activity of C, whereas C is succeeding activity of A. Have you got all of you? Yes or no? What is meant by preceding and succeeding activities? Have you got these things? What is meant by preceding and succeeding activities?
Yes, sir.
Okay, thank you. Then let us see dummy activity, right? So what is my dummy activity? Let us see. It is an imaginary activity which does not consume any resources, time, and time is called as a dummy activity, right? So activities are simply used to represent connection between we can say events in order to maintain a logic in the network. So it is represented by a dotted line in a network. Okay, so here you can see that the dummy activity, these are the activities A, B, C, and this is dummy activity shown with the help of the, you can say, just a dotted line, right? So it does not consume any resource or it does not consume any time also, right? So that is your dummy activity. So here you can see that where we can use this dummy activity, right? So here some examples are given. That means these are actually errors to be avoided in constructing the network diagram, right? When you are going to construct a network diagram, you should take care of this. You should avoid these errors, right? So first is what? The two activities starting from tail event must not have same end event. That means the two activities are starting from a single tail event should not be end at the single that means same end event, right? So to ensure this, it should be absolutely necessary to introduce a dummy activity in that case. Here you can see in the first figure, right? 1 and 2, these are the two events, and from this one two activities are we can say uh, bursting, right? That means two activities are going like this one and this, but these two activities again ending at same event, that is number 2, right? So we can say that two activities starting from tail event must not have same end event, right? It should be for this activity there will be other end event, it should be for the second activity there another event, right? But if they are coming to the again same event, then this will be not the correct network diagram, right? So for that you can provide the one dummy event in that, right? So dummy activity, actually here you can see dummy activity like this. Okay, the next the looping error should not be formed in a network as it represents the performance of activities repeatedly in a cyclic manner as shown in figure. So the looping error should not be there like this, that is 1 2 3 again 1, this cycle, right? In the network diagram, just we have seen in the previous 3 to 4 slides before that we have seen one the correct and incorrect network diagram, right? So remember that always arrows moves from left to right only, not from the right to left, right? In the backward direction, always arrows moves from left to right, that is in forward direction only in the network diagram. Otherwise it will create a looping error, right? Then next, in network there should be only one start event and one ending event as shown in figure. So you can see that there here you can see these are the two events, right? So these are not again same, right? Only one start event and only one end event should be there, right? Okay, the next, the direction of arrow should be flow from left to right, avoiding mixing of direction as shown in figure. Okay, so this is the arrows moving from left to right like this. Okay, it should not be moved from we can say right to left, that is it will form a wrong direction of arrow, it will form a looping error. Okay, so these are the some errors to be avoided during the constructing network diagram. Rules in constructing networks, that is first, no single activity can be represented more than once in a network, right? Then the length of an arrow has no significance, you can draw any size of length of arrow. Then the event number 1 is the start event, and event with highest number is the end event in the network diagram, right? Before an activity can be undertaken, all the activities preceding it must be completed, that is the activity must follow a logical sequence between the activities. Then third, in assigning numbers to events, there should not be any duplication of event numbers in a network. Fourth, dummy activities must be used only if it is necessary to reduce the complexity of network. The next, a network should have only one start event and only one end event. So these are the some rules to be followed while constructing a network diagrams, right? Some sign convention, some conventions of network diagrams are shown below. So what is the meaning of that? So first is like this, A, B, C. These are the, again you can say events are there. right? So activities are there, and with the 4 events you can see. So activity B, how to read this again, you can see that how activity B can be performed only after the completion of activity A. That means this activity B can be, we can perform only and only after completion of activity A. Same activity C can be performed only after completing the activity B. That means already activity A is done, right? Then next you can see these types of construction in the network diagram also. So how to read that? Activity B and C, that means these two activities B and C, can start simultaneously only after completing activity A, right? B and C can start only after completing activity A, whereas activity A and B, that means these two activities must be completed before start of activity C. This can be completed before start of activity C. Then next you can see that activity C, right, must start only after completing activity A and B, right? Whereas activity D, that means this activity, can start after completion of B, because you can see B is coming from this and you can start with D right after completing B. But here for C, these two activities, that is your A activity, this is dummy activity, that is B activity should be completed, because from B again the activity will go into the C. Okay, because the arrow is shown like this. So for completion, for starting the activity C, you should complete A and B activity, but for starting activity D, you should complete only activity B. There is no any effect of activity A on this. So these are the some conventions of network diagrams that we have to follow, right, during the constructing a network diagram. The next procedures for numbering the events using the Fulkerson rules, right? So let us see that. First, number the start or initial event as a 1. Then from event 1, strike off all the outgoing activities. This would have made one or more events as initial events. Each that means event which do not have incoming activities, number that event as 2. Then repeat steps 2 for event 2, event 3 till the end of the event. So the end event must have the highest number. Let us see with the help of one example how to draw the network diagrams, right? So draw a network for a house construction project. The sequence of activities with their predecessors are given in table below, right? So here you can see the table is given, right? That is sequence of activities for a house constructions of a project are given. So here you can see name of the activity is given A, B, C, D, E, F, like that. The starting and end and finishing events are given 1, 2, 2, 3, 3, 4, 3, 5, 4, 6, 5, 6, like that. The description of activity is given, that is prepare the house plan, construct the house, fix the door and window, wiring the house, paint the house, polish the doors or windows, like that. So this is what the description of this activity A, B, C, D respectively, like that. Here the predecessors of each activities are given. That means for activity A there is no any predecessor activity, but for activity B there will be a predecessor. For C there will be a B. For D B will be the predecessor activity. For E it will be a C, and for F the D will be the predecessor activity. The time duration for each activity is given, that is 4, 58, 2, 2, 1, 1, like that. Okay, is it possible for you to draw the network diagram with the help of this given data? Just I am asking about the network diagram with the help of activity and the predecessors of it. Events are given 1 to 6, like that. Is it possible for you? Yes or no? Let us see that how to draw this, right? So you can see that the here the starting event is you can say 1 to 2, right? So 1 to 2 activity for that is A, so you can just note that activity as A. Then for 2 to 3 again another event, that is 2 to 3, you can draw circle 2 and 3 here, you just connect that, activity will be B, right? So as you know that for activity A, that means there is no any preceding activity, that means before one there is no any event, right? But for activity B here you can see that there will be a predecessor of A, that means activity A will be predecessing. So for B, A will be the predecessor, right? Then next for 3 to 4 and 3 to 5 there will be event like that, 3 to 4 and 3 to 5, namely as activity C and D, C and D, like that. So we can say that for activity C, B will be the predecessing activity, for activity D, B will be the predecessing activity, again you can see like that. Okay, then 4 to 6 and 5 to 6 again, right, where E and F you can write down. For activity E, C will be the predecessing, and for activity F, D will be the predecessing activity, right? So like this way you can draw the network diagram, right? Just take an overview on this, right? If any query in this, you may ask in this network diagram. So this is very easy, right, to construct the network diagram with the given set of data. It's just a request for all, just take an overview on this network diagram. If any query in this, you can ask me, right? All of you have got this, yes or no?
Yes, sir.
Yes, sir.
Okay, so this is very easy, and the numericals are depend on these network diagrams, right? So you should know about this network diagram. So here the some theoretical depiction of this network diagram is given. So network diagram is shown in the previous figure, right? That is procedures relationship between the activities. So activity A, that is preparation of house plan, has a start event as a 1 and as well as the ending event as 2. That means for this activity A, right? So this is what preparation of house plan. Then next construct the house, that is second activity, right? So activity B, that is construction of house, begins at the event 2 and ends at event 3. So activity B cannot start until the activity A is completed. That means this before completion, that means before preparation of house plan, we cannot start with the construction of the house, right? So if you want to do the construction of house, you should be ready with your house plan. That means the activity of the planning of the house should be done, right? Then and then only after you can start the constructing the house, right? The next you can go for the fixing the doors and window, that is for the activity C. Simultaneously you can go for the wiring and house also, right? In the housing house also, right? So you can do these two activities simultaneously, that is C and D. You can do fix the doors, windows, you can do the wiring simultaneously, right? Then after fixing the doors and windows, you can go for the painting the house, right? And then after that you can go for, after that means wiring and wiring the house, you can go for the polishing of the doors and other things, right? So this is what the reading of this network diagram, right? Okay, let us say second example. Consider the project given in the table 8.2 and construct a network diagram. A sequence of activities for a building construct project is given. Same again, purchase of land, then that is activity A. Activity B is preparation of building plans. Activity C is level or clean the land. Then D is register and get approval. E is construct the building, and F is paint the building. The predecessors are given like that, dash dash A, A, B, C, D, like that. Okay, so here you can see that. So activities C and D have a common predecessor as A. That means for this activity you can see C and D common predecessors are A for C, and for D it will be A and B. These are the two predecessor activities for the D. So let us try to that. So the network representation shown in A, right? You can draw this type of network also, you can draw this type of network also. But what happened actually? Why these are incorrect, these two? Because here you can say figure A and B, that means this figure and this figure violates the rule that no two activities can begin and end at the same event. That means we have seen that the errors, right? So this is what the activity A and B are starting from same event and ending at same event. So this is not the incorrect, this is not the correct network diagram. This is incorrect network diagram. Here also you can see that A and B, right? These are started, right, but ending at the same activity, right? So this is not the again correct, because these C and D, here you can see A and B are ending at the same event, and again C and D is starting from the same event, like that. Okay, so this is not the correct way. In that case you can implement, you can use the dummy activity in between that, like this. Okay, so that's why this is the correct you can say network diagram for this problem. The next, construct a network for a project whose activities and their predecessor relationships are given here in the figure, in the table. You can see the activities are given A, B, C, D, E, F, G, H, I, J, K, like that. The predecessors are given for A, B, C there will not be any predecessors, but for D it will be A, for E it will be B, like that. Okay, so with the help of this data you can just draw the network diagram like this. So the network diagram for a given problem is shown in the following figure, right, with activities A, B, C starting simultaneously, like this. So you can take event 1, right, and the activities A, B, C are starting simultaneously, because for A, B, C there will not be any predecessor. So you can burst this event, right, that is like A, B, C. So you can name that second event, third event, and fourth event, like that. Then for activity D there will be A will be predecessor, so for you can take a second, from that you can draw the activity D. For E there will be a B, so from third you can take the E activity. For F again there will be a B, so from 3 again you can take the second activity. For G it will be a C, like this. Okay, and for H again it will be a D. So let us see, D is here, so you can take this H activity from this. For I there will be E, so from I you can take, right. Then for J there will be H and I, so that's why I is coming towards the 8 event, right. So for J it will be H and I, right. These are the two predecessors activity. For K there will be F and G, right. So for K there will be this F and G activities are there, so 7 will be taken here, and you can make the final one, that is ninth one will be your final event, right. So this is your starting event 1, and 9 1 will be your final event. You can check, you can take an overview all these activities. You can find that all the activities have given predecessors are there in this network diagram. Just take an overview while a minute. It is requested to all just take an overview on this network diagram. If any query in this you may ask. Okay, so I think it will be clear for all, right? Is it clear?
Yes, sir.
Okay, thank you. Let us see the next problem. Draw a network diagram for a project given in table. Again, the activities and immediate predecessors activities are given. A to L activities are given respectively. So an activity network diagram described in the project is shown below. So for A there will not be any preceding activity, so we can take 1 to 2 event and on that activity A can be shown. For B it will be A will be the producing activity. For C you can take right like that. For A activity, for B A will be there, right? For C B will be the activity, but for D there will be A, so that's why D is taken here, right? You can see. Okay, then for E again there will be D will be producing. Then again for F there will be a C, right? And also E will be there, so that's why C and E will be merging here at this event, you can see, right? Then for G there will be a D, right? So for G you can see D. Then for H also there will be a D, so that's why here bursting of the event will takes place at this event, you can see, for H, G and F, because of this E, F, E, H and G, right? So because E, you can see E, H and G, there will be a D only, the predecessor activity. Then for I again there will be H, you can see I activity will be here, right? Then J again you can see there will be H, right? Then for K there will be F and H, right? So here you can see K will be there, right? And F and H activity. Then next is L, that is for G, and for L you can see G and J activity will be there, right? So this is the activity where shown between you can say H and K, right? So because K is required to be completed after only F and H activity, right? So this is a simple network diagram, right? But as far as the point of gate perspective, there will not be any question will be asked on drawing the network diagram, but maybe asked like this, the some 3 to 4 activities are given and identify the correct network diagram. Also 4 network diagrams are also they give, right? Just for that information you should aware about this what is by predecessor activity and succeeding activity and how to draw the network diagrams. Okay, but majorly numericals will be asked on the CPM, that is critical path method, and PERT problems. So let us see before that CPM, right? That is how to find out the critical path from the network diagram. Before that, let us see what is in by A1 diagrams, actually, that is activity on node diagram. Okay, so it is observed from the above diagram, that is from the network diagram, that while constructing the arrow diagrams, that is conventional network diagram, many times dummy activities have to be included to represent the precedence relationship between the activities correctly. So that is to maintain the logic. This results in increased number of activities and lengthy and cumbersome the network and more time and efforts for the analysis. So the activity on node, that is A1 diagram, as the name suggests, that it represents the activities by nodes on circles with the arrows connecting them representing the precedence relationship between them. So though all the arrows in A1 diagrams are like dummies, since they do not require any time or resources and represents only the dependency relationship, yet no dummies are required in the A1 diagram, right? That means dummy activity there will not be any required to show on the A1 diagram, right? So the tail of each arrow is on the predecessor activity, while the head is on the successor activity, as shown in the figure, right? In which activity A and B, A precedes the B. So here you can see actually the arrow diagram will be like this. Okay, so A and B, these are the two activities, right? Here with the help of, you can say, these are nodes, actually these are actually what are the events here, right? But activity on node diagram, that means we here in this A1 diagram, activity on node diagram, all the activities like A3 or B5 are taken on the node, not on the arrow, right? Here we are previously in the network diagram we are showing on the arrow, right? So because of the dummy activity it will get too much complicated, right? So here you can directly take on the node and you can show that activities on the node also. So that's why here we are calling as an activity on the node diagram, right? So let us see one numerical on this, right? So the dependency relationship between the activities of a project are shown below. Draw the arrow and on diagram for it, right? So this is arrow diagram with the given data is shown, with the help of this it is shown, we have drawn, right? Okay, then A1 diagram, how to draw this, right? Because arrow diagram, that is network diagram, you can draw because A, B, C there is no any immediate predecessors. So for A, B, C activity, you can start from one event, right? Then for D, there will be A and B, right? So activity D he will be there. So from A and B you can go to D, right? But for E there is again B activity is also there, right? For E, so that's why you cannot directly connect B to this activity, right? Because for B is again dependent on the E, that means E is again dependent on the B activity. So that's why you have to take the one event and you have to show the dummy activity D1 like that. Okay, same for the F also, it will be depend upon your B and C, right? So F is not directly depend on the your we can say C or B. So here again you have to take the dummy activity D2, right? But this is arrow diagram. Now if you convert this arrow into a diagram, will be like this: your start, then activity A on node, activity B on node, and C on node, right? Then again B to D will be their activity another, then for B to E and B to F, because here you can see D for D B will be predecessors, for E B is a predecessor activity, for F also B is a predecessor activity. So like that you can go for D A is a predecessing activity, again you can see that. For E there will be only B predecessor activity, but for F B and C will be the predecessing activity, right? So we have taken the activities on the nodes only, right? So this is called as an Aeon diagram, and after that there will be your end event. Okay, so here in this diagram if we compare arrow diagram with Aeon diagram, here in Aeon diagram there will not be any need of dummy activity, right? So it will reduce your complications in the network diagram. That is one advantage of Aeon diagram. Okay, now let us move towards the CPM, that is critical path method. That is our point of study in this session actually, as far as the GATE point of view. So critical path analysis, how to analysis the critical path from a network diagram, right? Which one is the critical path? Because all of you know that for completing any project we have different ways, right? From any way we can complete that project, right? You can follow the different methods, methodologies, you can follow different steps and you can achieve that output, right? But in some ways, right, there will be some criticality, right? There should be some failure, right? Or it may consume some times, right? So how to find out that critical path from the given we can say network, right? From the given path. So let us use this critical path that is CPM techniques for finding out these critical path methods, right? So the critical path of a network gives us the shortest time in which the whole project can be completed. It is the chain of activities with the longest time duration. These activities are called as actually critical activities. They are critical in the sense that a delay in any of them results in the delay of the completion of the project. So that's why we are calling it as a critical path, actually critical activities. So they are there may be more than one critical path in a network, and it is possible for the critical path to run through a dummy activity. So critical path analysis consists of the following steps. That is, first, calculate the time schedule for each activity. It involves the determination of time by which an activity must begin and the time before which it must be completed for each activity. The time schedule data for each activity include the calculation of the earliest start, the earliest finish, the latest start and the latest finish time for and the float of the activity. The next second step is calculate the time schedule for the completion of the entire project. It involves the calculation of project completion of time. The next, identify the critical activities and find the critical path. Critical activities are ones which must be started and completed or on schedule, or else the project may get delayed. The path containing these activities is the critical path and is the longest path in the terms of duration also, right? So let us see with the help of one numerical how to find out the CPM, that is critical path method analysis, right? So consider the network shown in figure, that is bottom one figure, which consists of the following activities. That means activities are given and its durations are given. Now in this case the network is also given, because here the preceding activities are not given, so there is no need to draw the network also, right? The network is also given and the durations are also given. So activity 1 to 2 the duration is given 15, for 1 to 3 duration is given 15, like that. Okay, so it is just an weeks, right? Now in this diagram, just see the network, right? Just see the numbering 1 2 3 4 5 6 7, right? That is what the activity is. Don't see that E and L that is mentioned on each node, right, or each activity. So can anyone tell me, just it is a arrow diagram or it is activity on node diagram, on diagram?
Arrow diagram.
No. This is on diagram. That is activity on node diagram. All of you know that what is meant by node. That is, here you can see that circle is a node, right, in the diagram. So in that circle you can see that 1 2 3 4 5 6 are mentioned, 7 up to that. So that is what actually activity. Activity 1 to 2, that is your this activity. That is activity is taken on the node. Okay, 2 to 3, 3 to 4, these are the activities are taken on the nodes, not on the arrow, right? So that's why it is on diagram. Okay, now don't see that E and L. What is E and L we will discuss in ladders, right? Just see this diagram carefully. Now for activity 1 to 2, right, duration is required is 15 days. Similarly for 2 to 3, right, it is 3 weeks. Then for 1 to 3 activity, duration is required 15 weeks. That is just mentioned on that arrows. Right, so for each activity, that is for 2 to 5 activity, you can see here 2 to 5, this activity, the weeks required, duration required is 5 weeks. For performing activity 3 to 4, that means this activity, duration required is 8 weeks. For performing activity 3 to 6, that means this activity 3 to 6, duration required is 12 weeks. For 4 to 5, duration required is 1 week. For 4 to 6, duration required is 14 weeks. For 5 to 6, duration required is 3 weeks, and for 6 to 7, duration required is 14 weeks, like that. Okay, so like this, for each activity the durations are mentioned here on the arrows actually, right? Activities are taken on the nodes. Okay, now you have to find out what you have to find out actually the critical path, right, from this activity.
सर ते E आणि L चा काय येतं, म्हणजे काय ते?
Yes. Actually that is your earliest start time and latest start time, earliest finish time and latest finish time. So how to calculate that E and L? Actually that we required. EL, that is your earliest start time and earliest finish time, latest start time, latest finish time, we require to calculate the float. So how to calculate that EL and float, we will see with the help of the table, right? So just now don't consider that E and L will be there in this diagram. Just this is the diagram with you, network diagram. Okay, and E and L will be there. Sir. So here you can see that E and L will be there. Okay, don't consider that E and L will be there in this diagram. Okay, so let us see that what is meant by earliest start time, right? So for an activity represents the time at which an activity can begin at the earliest. It assumes that all the preceding activities start and finish at their earliest time. For instance, earliest start time of activities 1 and 2 are 0, right? That means that is earliest start time will be indicated by E only, and your latest start time, right, that is latest finish time will be indicated by term L. Okay, just remember E stands for earliest start time, whereas L stands for latest finish time. Okay, now for instance, earliest start times for activities 1 and 2 and 1 and 3, that means for activity 1 to 2 and 1 to 3. Here what will be the earliest start time? That means E only. Now see, for only E, we are now discussing about the E. For starting the activity 1 to 3, what will be the start time? Is there any activity behind the 1? There is no any activity, right? You are starting from the 1 to 2, right, or 1 to 3. Is it correct? Is it correct?
Yes, sir.
just see with that diagram, right? Don't see EL values mentioned there, right? Okay. Now for let us say we are starting from the 1 point, right? 1 to 2 activity. Now for earliest start time, right, for this activity, that means for 1, right? What will be the earliest start time? Is there any activity is going behind that 1? There is any activity behind that 1?
No.
There is no any preceding activity, so earliest start time will be E. For that one will be 0. Remember, E will be 0. So you can see that on one node E will be written as 0. Are you getting that? Are you able to see that E will be 0? Okay. Now let us move to the second activity, that is activity number 2. Okay. So on that 2, what is the earliest start time? Because for performing this activity 1 to 2, it requires 15 weeks, right? So what is the earliest start time? After completing this, you can start the second, that means you can move forward for 2 to 3 or 2 to 5 activity, right? So for that you require the 15 weeks to be completed. Is it right? So earliest start time for the second activity will be 15. E is equal to 15. Are you able to see that in the second node E is equal to 15 is written? Yes or no?
Yes, sir.
Okay, for 3, activity 3, now here on the node 3 you can see that on node 3, right, you need to find out the earliest start time, that is E. Now here you can see activity 3 can be completed like that 1 to 3 or 1 to 3 or 2 to 1 to 3 like that. Okay, you can perform this activity 3 like this 1 to 3 or 1 to 3 like this. Okay, so for earliest start time for this activity 3 will be your this time, that is 1 to 3 will be 15, right? Because before 1 there is 0, right? So 0 plus 15 it will be 15. Otherwise from 1 to 3, 1 to 3 it will be 15 plus 3, 18. So you have to take the maximum in that case. You have to take the maximum, it is 18. So 15 plus 3 will be 18. So that's why maximum is taken as 18 and minimum is 15, that is from 1 to 3. So from these two way you can complete the activity 3, right, by 1 to 3 or by 1 to 3 like that, this path, by following this path. But from the maximum time which required that path, you have to take that E value, that is earliest start time, that is 18. That is given here, right, in this paragraph. You can see that for instance earliest start time for activity 1 and 2 and 1 and 3 are 0 each, or the earliest occurrence of time event 1 is 0. Earliest start times of activities sorry, 2 and 3 and 2 and 5 for the earliest occurrence of the event 2 is obtained by adding the activity T1 to earliest occurrence of time T1 2, right? That is 15 here getting. Next, consider the event number 3, that means this one. It can be reached directly from event 1 or via event 2. The times for 2 sequencing begins 15, right, and 15 plus 3, so that is 18. Since event 3 can occur only when all the preceding activities and events can take place, that means this event 3 can occur only and only when this activity, both this activity 1 to 3 and 1 to 3 will done, right? So that's why you have to take the measure value, that is the maximum value, that is E is equal to 18. Now same for the 4 activity, right? Same for the 4 activity. How we can calculate the E value? Can anyone tell me for the activity number 4 now? Earliest start time for the activity 4. E value, because 4 will coming from the 3, right? So 3 is having E value as 18. So 18 plus the time required, duration required for 3 to 4, it is 8. So 18 plus 8 will be 26. So it will be a 26 for the 4. there is only one activity, there is no two activities coming to the 4, right? So you just take only what are the single activity there. Then 4 to 5 again you can check, right? Now 4 to 5, this 5 activity can complete, can start, right? That is, it can start when only when the 4 activity and second activity will complete, right? Because for 5, 2 to 5 there will be activity, and 4 to 5 also there is one activity. That is, here the merging of the activity will take place. So this activity, 5 activity, can only when start these 2 activities has completed. So let us see that for 4 to 5 how much will be time required, right? So 4 to 5 you can see is 26 up to 4. So 26 plus this one, that is 27, right? And here you can see that is 15, 15 plus 5, that is 20. So out of that you have to take maximum value, that is 27. So that's why here for 5 E is getting as a 27. For 5 activity, E, capital E is getting as a 27. We are discussing about only E, we are not discussing about L, right? The next, for activity number 6, now you can see here in the activity number 6 there are 3 activities are depend on this, right? So that is 3 to 6, 4 to 6 and 5 to 6. That means we can say that the activity 6 can only when start the activity 3 has completed, the activity 4 has completed and 5 has completed. So let us see that how much will be the earliest start time for that. So from this again, at 3 the E will be 18. So 18 plus 12 it will be a 14, 40, 40, sorry, it will be 30, 30, right? Then again from 4 it is 26 E, then 26 plus 14 it will be a 40, right? Here we are getting as a 30, here we are getting as a 40, right? Then at 5, that is 27 plus 3, again it is 30. So maximum will be what out of these 3? 30, 40, 30. Which one is the maximum? Can anyone tell me?
40.
40. So that's why E will be getting here as a 40 for the 6th one. We have to take the maximum, because why? The activity 6 can start only when the activity 3, 4 and 5 have completed. But for completing this activity 4, it requires a time of 40 weeks. So that's why E will be taken as a 40. And now again from 6 to 7 there is only one we can say a single activity, that is 7 activity will be depend only on 6. So for 6 it requires the time as 40 weeks. So 40 plus 14 it will gives us 54. So all of you got this, how the capital E is calculated? Yes or no? Can anyone tell me?
Yes, sir.
All of you can take the overview on all the E's, how it will be calculated, right? Just from initial event you have to start, because for initial event the earliest start time will be your 0, and then you have to start from 1 to 2. You can take from 0 it will take 15 days, sorry 15 weeks. So 0 plus 15 E will be 15 here. Now for third you can see it will be come from 2 to 3 and 1 to 3. That means your third activity can start only and only when the activity 1 to 3 completed and activity 2 to 3 have completed. So let us see how much will be time required for 1 to 3. It is 15, and for 2 to 3 this 15 plus 3, that is 18. So maximum time you have to take, that is 18 weeks. Same for the 4, you can see the 4 activity can only when start after completing activity 3, that is 18 plus 8 these weeks, so it is 26. Now again for 5 you can calculate the E value, earliest start time. So activity 5 can only when start the completing activity 4 and 2. So for this 5 start we require the time will be 26 plus 1, that is 27, and for this is 15 plus 5, that is 20. So you have to take the maximum, that is 27 here. Same for the 6 we have calculated 40, and same for the 7 it will be 54. So just take an overview on these capital E values. Have you got that how it will be calculated? Yes or no? All of you requested to just take an overview on this capital E, that is earliest start type. If you have got this, we will move further.
Yes, sir. Got it.
Okay. Now take an example, right? Take the activity 1 to 2 here only, right? So 1 is called as actually I, and 2 is called as J. So EI from that is from activity 1 to 2, EI will be 0 and EJ will be what then? Can anyone tell me EJ value how much will be from activity 1 to 2? We are calling I 1 as a I and 2 as a J. So EI will be 0, then what will be the EJ value? It will be 15. It will be how much? 15, because 2 is a J, right? We are corresponding to it will be term as a J. So EJ will be 15 like that. Same for 2 to 3. If EI will be 15, then EJ will be 18 like that. Here also. Okay. Now just you need to draw the table, right, like this. Okay, for solving the numericals. Actually in that table you can see that the activity ij, right, like that 1 2 3 1 to 3 1 to 2 to 3 3 to 2 to 5 3 to 4 like that you have to mention, right, the durations. That is second column. Then third column will be your early start time earliest and latest, then finish time earliest and latest. How to calculate that we will see in detail, float and other things, right. So before that let us see how to calculate the L values also, right. That is capital L you are seeing here, right. So that is L is what? That is your latest finish time. L is what? Your latest finish time. So how to calculate? Now from for calculation of L you need to start from the end event, right, that is from the 7. So for end event write the L value as it is, whatever it will be the E value, so that is 54. Then for 6 calculation of for L value for the 6, just subtract the time duration, that is from your previous L value, that is from the 7, that is 54 minus 14, it will be a 40 for this case. Have you got this for 6 how we have calculated the L? Yes or no?
Yes, sir.
Okay. The next for the fifth you can calculate like that. Okay. 40 minus 3, it will be how much? 37, right. So you can see that L is noted here 37. Okay. For fourth again you can calculate L, that is from this value L, that is 40 minus 14, that is 26. Same for the third, you can calculate that 40 minus 12, that is 18. Okay. Now here that is L is 37, 37 minus 5, it is 32. And here also you can see that you can calculate by this way also, 2 to 3, that is 3 to 2. 18 minus 3, that is 15. But here for 2, remember for 2 L value we can calculate by two methods, that is by 2 to 5 or 2 to 3. 2 to 5 we are getting as a 32 and 2 to 3 we are getting as a 15. Here it is mentioned as 15 only, right. So you need to take the smallest value of L, right, in this case. Remember that for E you need to take the highest value and for L you need to take the smallest value. Are you got this? Have you got this? So that's why the L is taken as a 15 for the second, and for 1 15 minus 15 0. Here also you can take that, right. So that is 1 you are getting as a L as a 0. Okay, yes or no? Have you got this?
Yes,
How the L is calculated, right. So that is your latest finish time. Okay. So all these are given here in this theoretical part, right. You can read that. I will share this PPT with you also, right. So you will get the too much clear idea, the formulas and other things. So now you need to prepare this table, right. So that is activity. First is activity I to j, that is 1 to 2, 1 to 3, 2 to 3 like that. Then its duration in the weeks you need to write that, that is given data. Then next columns will third and fourth column of start time and fifth and sixth column of finish time. So in third and fourth column in third column you need to write the earliest start time and latest start time, and in finish time you need to write that earliest finish time and latest finish time, and then float. So this earliest start time, right, that what we have calculated as a E, you have to write down here, right? Here you can see that is your EI values only. EI means what? You can see that for activity 1 to 2, EI is what? 0, right? So here you can see that EI is 0, that is for 1. I means for what? 1. J means for second. So for E1 is 0, you can see, right? So that's why here it is 0. Same for 1 to 3, EI value is what? 0. Same for 2 to 3, that means 2 to 3, EI value is what? 15, that is written. For 2 to 5, EI value is what? 15. I means what? That is for 2, that is your first activity. In 2 to 5, the first activity is 2, right? Then for 3 to 4, again you can see that 3 to 4, right? EI is your 18, that is third, right? Then 3 to 6, that means this, EI is 18. Then 4 to 5, again 4 to 5, EI is 26. Then 5 to 6 and 6 to 7, the values of EIs are noted, right? Then this column, that is third column, you can write from the E values, right? Then next column, that is, this is third column, right? Fourth, fifth and sixth column, that is your latest finish time, that is your LJ values, right? You can write after calculating the L value, right? These are the L value we have calculated on each activity, right? So that is LJ column, that is LJ, not LI. LJ means what? Your second activity, that is in 1 to 2, second activity is 2. In 4 to 6, second activity is 6, not 4. In 4 to 5, J is your 5. In 3 to 6, J is 6, like that. So let us see that with the help of this diagram again. So for 1 to 2, that means for this 1 to 2, LJ is what? L of 2, that is 15. For 1 to 3, LJ is what? L of 3, that is 18. You can see that values are noted here. Okay. Then for 2 to 3, L of 18, that is LJ, right? That is of we can say 3, that is 18 again. Then for 2 to 5, that means 2 to 5, LJ, that means L of 5, J means 5, so that is 37, you can see. Same for all the LJ's values are noted, right? And now from this EI and LJ tables, you can calculate the latest start time and earliest finish time, like that. So how to calculate latest? For latest start time, the formula is LJ minus T. That means this LJ you have to take, and the time duration will be this one. So LJ minus T, that is 15 minus 15. This 15 minus this T, the LJ minus T, that is 0. Then 18 minus 15, 3. Then 18 minus 3, 15. Then 37 minus 5, 32. 26 minus 8, 18, like that. 40 minus 12, 28. You can just write down these values, LJ minus T. Same here, for earliest finish time, you can use this formula, EI plus T. EI is known value, T is this one column, second column. So you can take EI plus T. So just make the additions of these two, you can write this column, right? Then let us see how to calculate the float. Float is nothing but what? This difference, column difference, that is 6 minus 5 or 4 minus 3, like that. Okay, so this will give us the float. You can see that is total float. So column number 7 can be calculated as column 6 minus column 5 or column 4 minus column 3, right? So 6 minus 5 or 4 minus 3, you can take any one difference you can take. You will get the same values for the float. That is here 15 minus 15, 0, 18 minus 15, 3, then 18 minus 18, 0, 37 minus 20, 17, 26 minus 26, 0, 40 minus 30, 10, 37 minus 27, 10, 40 minus 40, 0, 40 minus 30, 0, 54 minus 54, 0, right? So here you can see that the float values are getting. You can check with this, cross check with the 4 minus 3 also. From this you will get the same values. Now why it is necessary to calculate the float? Actually this float will give us the critical path from the given network, right? Which one is the critical path? Because with the help of this diagram you can say that means your 1 is your starting activity and 7 will be ending activity. So you can perform this activity like this also, that is 1, 3, 6, 7, or you can perform like 1, 2, 3, 4, 6, 7, or you can perform like this 1, 2, 3, 4, 5, 6, 7, or you can perform this project like this 1, 2, 5, 6, 7. So anyway you can perform this project, right? You can perform these activities, you can complete these tasks. But from all these path, right, there are 4 paths are there. So out of these, how you can see these, which are these fourth, right? So that is first 1 3 6 7, that is first. Then 1 2 3 4 6 7, that is second. Or more than 4 paths are there. Then 1 2 3 6 7 will be there another. Then that is third. 1 2 4 5 6 7, that is fourth one, right? Then 1 2 4 sorry, 1 2 5 6 7, that is a fifth one, right? So more than 4 5 paths are there, right? So out of these all paths, which one is the critical, how we can identify? So you can identify with the help of float. So for the activity which is having the float 0, right, you can take that activity. That is for activity 1 to 2, the float is 0. For activity 2 to 3, float is 0. For activity, you can say 3 to 4, float is 0. For activity 4 to 6, float is 0. And for activity 6 to 7, float is 0. So you can take that activity 1 to 2, 2 to 3, then 3 to 4, then 4 to 6, and 6 to 7, right? So this will gives us the critical path actually, right? So the float or activity 1 to 2, here it is written, right, is 0. Similarly, calculate the total float for other activities. Critical path is the path containing activities with 0 float. That means the activities which are containing the 0 float, these are actually critical path, right? So from this you can say that 1 to 2, 2 to 3, 3 to 4, 4 to 6, and 6 to 7 is a critical path actually. So that's why it is indicated with the help of double arrows here in this diagram. You can see that, right? So this is a critical path actually. 1 to 2, 2 to 3, 3 to 4, and 4 to 6, 6 to 7, like that. Okay, so this is a critical path actually, right? And the time duration for that project is a 54 weeks for this path. Okay, otherwise with the help of this you can see the duration will be for 1 2 5 6 7. How much will be the duration? Can anyone tell me? For 1 2 5 6 7, the project can be completed with the this activity also, like this flow 1 2 5 6 7. So how much will be duration it will take? Can anyone tell me? Fifteen plus 5, that is 20. 20 plus 3, 23. 23 plus 14, that is 37, right? But for the path you can see that 1 2 3 4 5 4 6 7, it will be 15 plus 3 8, 8 plus 8 sorry, 18 plus 8, it will be 26. 26 plus 14, it will be 40. 40 plus 50 of 14, which will gives us 54. So that's why it is a critical path actually, right? So like this way you can calculate the critical path from the given data, right? So let us see what are the different types of floats. That is there are basically 4 floats, like total float, free float, independent, and interfering float, right? So total float is what? It is the difference between the maximum time available to perform the activity and the activity duration. So the maximum time available for an activity is from the earliest start time to the latest completion time, right? Then free float is what? It is the it is that the portion of the total float within which the activity can be manipulated without affecting the floats of subsequent activities. It is computed by subtracting the head event slack from the total float, right? So that is L minus C, you can see. Then independent float is what? It is that portion of the total float within which an activity can be delayed for a start without affecting the floats of preceding activities, and it is computed by subtracting the tail event slack from the free float. If the result is negative, it is taken as a 0 also, right? The next is interfering float. It is utilization of float of an activity can affect the floats of the subsequent activities in the network. So thus interfering float can be defined as the part of the total float with which causes a reduction in the floats of succeeding activities. So in other words, it can be defined as the difference between the latest finish time of the activity under the considerations and the earliest start time of the following activity, or 0, right? So whichever is the larger. So these are the different types of we can say float. Then the activity, subcritical activity, supercritical activity, Let us see what is meant by subcritical activity. So activity having next higher float than the critical activity is called as the subcritical activity, and demands normal attention but allows some freedom of action also. So the path connecting such activity is named as a subcritical path. Supercritical activity is an activity having negative float is called a supercritical activity. Such an activity demands very special attentions and actions also. It results when the activity duration is more than the time available also. Then slack is what? It is the time by which occurrence of an event can be delayed, right? So that is slack. So these are the sums, the terms are there, right? You should know about this, right? Then another same example on this finding out the critical path and time duration, as we have seen the second problem in the second slide, right? At the earliest of this session, we have seen some problems will be asked from the CPM, that is critical path method. So find out the critical path for the given network diagram and how much will be the time duration for that. So again you can see here your starting activity is 1 and ending activity will be 6, right? So you can complete this project by different ways, like A, E, right? Or you can perform like A, D, F, I, like that, or you can perform like B, F, I, or you can perform with C, G, I, or you can perform like C, H directly, like that. So from that, out of which you have to find out the critical activity again, right? So again you can calculate the E and L values like this, okay, for all these, that is 1, 2, 4, 3, 5, 6, all you need to find out E and I, right? How to calculate E and E and L we have discussed already, right? Okay, so just calculate the E and L for all these, right? Then calculate the earliest start time and latest start time, earliest finish time and latest finish time. So earliest start time is nothing but your EI values, and latest finish time is nothing but your LJ values, right? So first write down all these EI and LJ values and just use this relation LJ minus T for calculating the latest start time, and EI plus T for calculating the earliest finish time. And float is nothing but what? It is difference between your these two values, that is earliest finish time and latest finish time, or you can calculate with the latest start time and the earliest start time difference, right? That is float. And whenever you are getting the zero value for that activity are actually critical activities, and you will get the critical path from that. So in this case you can see for 1 to 2 activity the float is 0, for activity 2 to 4 the float is 0, then activity 4 to 5 you can say float is 0, and 5 to 6 the float is 0. So these are the actually critical activities. So the critical path is what? 1 to 2, then 2 to 4, then 4 to 5, and 5 to 6. In this diagram you can see that critical path is shown with the double arrows sign, right? So that will gives us a critical path for this project, right? And you can see that time duration for that is taking as a 44 right durations, right? That is 44 actually here it is given in the time only, right? So 44 it will be we can say hours or something like that, right? So unit is not given, let us say we assume that it will be hours, so it will take some 44 hours. So this is what the critical path here. Okay, now this is about the CPM problems, right? These types of problems may be asked. Another method to calculate, right? This is one of the method to calculate the critical path in the given network, right? So there is another method to calculate the critical path. Let us see which one is this. So method 2 is that for identify the critical path the following conditions are to be checked. If an activity satisfy all these three conditions, then we can say that it is a critical. So first is what? E is equal to L for the tail event. That means here you can see that E is equal to L for all the tail event. Tail event means what? Your starting event. This is 1. You can see that E is equal to 1 L. So for all the events you can see that E is equal to L. Here also E is equal to L. Here also you can see that E is equal to L. E is equal to L, right? Here on 3 you can see that E is not equal to L, right? So that's why it is not in the critical path, right? Then next E is equal to L for all the head event also. For head event also you can see that this is head event for 1 to 2, so E is equal to L. For 2 to 4 head event is 4, E is equal to L. For 4 to 5 head event is 5, E is equal to L. 5 to 6 head event is 5. For 1 to 3 head event is 3, so E is equal to L not. So that's why it is not in the critical path. The next Ej minus Ei or Lj minus Li is equal to Tij. You can say Ej minus Ei, that means here for 1 to 2. Ej minus Ei, that means 8 minus 0, it will be 8. Lj minus Li, 8 minus 8, 8 minus 0, it will be 8, which is equal to your time, that is 8. Same for 2 to 4 also you can take, you can check. Ej minus Ei, that is 18 minus 8, will be 10. Lj minus Li, that is 18 minus 8, will be 10. So 10 will be your time duration here. 4 to 5 also you can check that. Ej minus Ei, that is 35 minus 18, it is 17. Lj minus Li, that is 35 minus 18, again 17. Same for the 5 to 6 also you can check. Here also if we check for 1 to 3, you will get Ej minus Ei, that is 8 minus 0, it will be 8. But Lj minus Li, that is 17 minus 0, will be 17. So these are not equal to 8. So that's why here it is not in the critical activity, right? So if all these three conditions satisfy, you can say that path will be in a critical, it is a critical path, right? That activity in the critical path. So that's why the critical path is therefore 1, 2, 4, 5, 6 will be there. Another method is that just simple, this is very simple method. The various paths and their durations are, you need to find out. Just write down the paths. So in this case the path can be actually like this: 1, 2, 6, 1, 2, 4, 5, 6, 1, 4, 5, 6, then 1, 3, 5, 6, and 1, 3, 6, like that. All these paths are noted, and just time durations are noted for each path. So for 1, 2, 6, for this path the time duration required is 8 plus 16, it is 24. So that is noted. For 1, 2, 4, 5, 6, that means for 1, 2, 4, 5, 6 the duration is required 44. Just summation of duration is taken, that is in days is taken here. So then for other path 1, 4, 5, 6, 1, 3, 5, 6, so you can check that and just take the maximum will be the longest. It will be a critical, obviously. So path 1, 2, 4, 5, 6 will be the longest in time involving 44 days. Is a critical path, and it is represented by a bold line. Here you can see. So in this case there is no need to calculate this latest, earliest, start and finish times, right? So in GATE exam, right, there is no need to calculate all these things, right? You just calculate. If they have asked that calculate the critical path, the time duration required for that, right? So you just take the all these paths, you just draw this network diagram, you just take the all these paths and how much duration is required and take the maximum duration, that will be a critical path. So simple, right? Okay, so how we can easily solve these problems, right? If we solve the standard methodology, then you need to calculate the earliest, latest start times and all these things, right? But as far as the competitive exams are concerned, you can use this method number 3 for calculating the critical path. Very simple, and you will get the easily within a fraction of seconds you can calculate the critical path and how much will be the time duration required, right? So you can solve the problem easily for 2 marks with this. Have you got this trick? Yes or no? If we solve that conventionally, it will take too much of time. Yes or no? Have you got these things?
Yes, sir.
Okay. So these are the again numericals, right? For an practice purpose, you can solve this. All right. Then let us see what is by PERT, right? So a PERT is an program evaluation and review technique, right? So let us see what is that. So the time estimates for the CPM system of a network omits the probabilistic considerations and is based on the single time estimates of the average time required to execute the activity actually. So in PERT analysis, the time duration of each activity is no longer a single time estimate, but is a random variable characterized by some probability distribution. So usually a beta distribution to estimate parameters of beta distributions. the PERT system is based on three time estimates of the performance time of an activity, because your CPM is not gives us the probability of the project completion within a given period of time. With the help of PERT technique, you can calculate the probability such that the project can complete within given period of time, right? So for that you need to study about the three time estimates, right, of the performance of an time of an activity. One is that optimistic time estimate, then second is pessimistic time estimate, and third one is the most likely time estimate. So let us see what is that optimistic time estimate. So the shortest possible time required for completion of an activity. If all goes extremely well, no provisions are made for delays or setbacks while estimating this time. That is your optimistic time. It is represented as TO, and it is given as it is termed as value A, right? The next, pessimistic time estimate. This is the time maximum possible time the activity will take if everything goes bad, right? So however, major catastrophic failures such as earthquakes, floods, storms, and labor troubles are not taken into the account while calculating or while estimating this time. And last one is the most likely time estimate, that is denoted as TM or M. So the time an activity will take if executed under normal conditions. It is the modal value. It is assumed that the situation is normal with usual setbacks or the lapses, right? So the frequency distribution of a PERT is given like this. So we have three time estimates for a PERT activity: the optimistic TO, the pessimistic TP, and most likely time TM. So in the range from optimistic to pessimistic, there can be a number of time estimates for the activity. If a frequency distribution curve for the activity times is plotted, it will look like one as shown in figure 14 point, that means in the bottom one figure. So it is assumed to be a beta distribution curve with the unimodal point occurring at TM and its end points occurring at TO and TP. So the most likely time need not be a midpoint of TO or TP. So hence the frequency distribution curve may be skewed to the left or to the right of, or it may be symmetric. So the assumptions of beta distribution, however, is not flawless, and the calculations made on these assumptions may sometimes be in error to the tune of 30%, right? So here you can say you may gives us the plot like a symmetric to be left or to be right skewed, right? So that's why though the curve is not fully described by the mean mu and the standard deviation sigma, so yet in PERT the following relations are approximated for the calculation of mean, then standard deviation, and the variance will be like that. So variance can be calculated as variance is equal to sigma square, which is equal to TP minus TO divided by 6 bracket square, right? So that will give us a variance. From that you can calculate the standard deviation, because variance standard deviation is nothing but what under root of your variance, right? So standard deviation you can calculate as TP minus TO upon 6, and whereas the mu, that is the you can say mean can be calculated as TO plus 4TM plus TP divided by 6. So from that, expected time or the average time of an activity is taken equal to the mean, and this is the time that the activity is expected to consume while executed. So thus T can be calculated as T is equal to mu TO plus 4TM plus TP divided by 6. The expected time is then used as the activity duration, and the critical path is obtained by the analytical method explained earlier. So the variance or standard deviation is used to find the probability of completing the whole project by a given date. So the variance or standard deviation is used to find the probability of completing the whole project by a given date. So the underlying procedures is as follows to be followed for calculating that. Okay, so before that you should know the relations between the variance and the mean and the standard deviation, right? Which are related to the your three time estimate that we have seen, right? That is your mean time, TO, TM, and TP, right? So that we have seen here. So TO is your optimistic time, TP is your pessimistic time, and most likely time is your TM, right? So all these three values are known for your time estimations, and you can calculate all these, right? The probability how we can calculate, let us see with that. So the compute the variance of all the activity duration of the critical path, and then add them up and take the square root to find out the standard deviations of the total projection duration, and denote it by sigma. Now while beta distribution curve approximately represents the activity time frequency distribution, so the project expected time follows approximately a normal distribution curve. So the standard normal distribution curve has an area equal to unity and a standard deviation of 1 and is symmetrical about the mean, right? So that is, you can use this relation for calculating z, that is z is equal to t minus tcp upon 6, where z is is the number of standard deviations, right? Scheduled time, and target dates lies away from the mean and expected date, right? Where t is your called as desired time, due time, or contractual obligation time. TCP is your expected time to complete the project also, right? And sigma is standard deviation. So with the help of one numerical, actually we will see that how to calculate the probability of the occurrence, right? So here consider the network for each activity. The 3 time estimates are given, TO, TM, TP are given here. You can see that. Determine the variance and expected time. So in this numerical, only variance and expected times are asked to calculate. So you can see the activities are given 10, 20, 30, 70 like that, 10, 50, 60, 70 like that, 10, 20, 40, 70 like that. Okay. So for all these activities, TO, TM, TPs are given on the arrow. You can see, right? You need to calculate the variance and expected time. So how we can calculate the variance is nothing but what sigma square, and it is your TP minus T0 upon 6 bracket square. So from that you can calculate the variance for all the activities. Also you can calculate the expected time, that is T. It is nothing but TO plus 4TM plus TP divided by 6. So you will get the T for all the activities. So this is just an calculation of variance and expected time for each activity, right? With the help of these 3 times you can calculate the expected time also, right? So like this you can calculate. The next important numerical along that is calculations of the probability, right? That again we have seen in the first slide, right, of the session. So calculate the probability that the project can be completed within given period of time, right? So let us see how the numerical can be asked like that. Consider a network as shown in below figure. The 3 times estimates are given. The expected activity durations and the variance are shown in along with the arrows. So the earliest expected times and the latest allowable occurrence times are computed and put along the nodes. So what is the probability of completing the project in 12 days, 14 days, and 10 days? So here you can see that all the datas are given, the times variance are given, estimated times is given, variance is given. So it is asked that what is that probability that project can complete within 12 days, what is the probability that project can complete in 14 days, and what is the probability that project can complete in 10 days. So you can see that the critical path is also given in this case, right? So let us see that we identify that the path is 1, 2, 3, 5, 6 is a critical path, and expected project length is 12 for that. That means for this you can see 1, 2, 3, 5, 6. Project length is given as it is L is equal to 12 at the last, you can see, right? So 2 plus 4 6, 6 plus 3 9, 9 plus 3 will be 12. So that's why length will be 12. So the project length is 12. Now for these 12 days, but here they are asking that what is the probability that project can complete within 12 days, or it can complete within 14 days, or it can complete within 10 days. So let us calculate one by one. Okay, so for 12 days you can see that here TCP is equal to 12 days, right? So let us take that TCP is equal to 12 days, that is we have to calculate. T is your 12 days, right? So critical path is 12 days actually, and you have to calculate for 12 days also, right? So T is equal to 12 days we are taking. Now let us calculate the standard deviation, that is sigma. So standard deviation for a project length, that means for this length a total 1, 2, 3, 5, 6 will be your summation under root of summation of all the standard deviation, that is for ij, right? Summation of sigma ij square we can say. So sigma is equal to under root of, right? Sigma is equal to under root of 1 by 9 plus 1 square plus 16 by 9 plus 1 by 9 like that. Okay, so under root of 1 by 9 plus 1 plus 1 by 16 by 9 plus 1 by 9. So it will give us sigma is equal to 1.73. Here you can see that sigma square is given, right? 1 by 9, 1, 16 by 9, and 1 by 9. So just we have taken that values, summation of all sigma ij square, right, in under root. So that will give us sigma value, it is 1.73. Now normal deviation, that is z is equal to t minus tcp upon sigma. So t is for 12 days we have to calculate, so 12 minus critical path is having we can say 12 days again tcp, so 12 minus 12 divided by sigma, that is 1.73. it will be 12 minus 12 0 divided by 1.73 will be 0. So you can see that the probability of completing the project will be 50%, right? So because here from this table, right, when z is equal to 0, psi will be 0.5, right? So that is a 50% will be probability. From that table you can calculate, right? Okay, so here also for 14 days, let us see for the second, you need to find out for the 14 days. So here t will be 14 days, so we'll just put the value of t 14 here. tcp is your critical path, that is for it is 12 days. So 14 minus 12 divided by 1.73, again sigma will be a common, that is 1.73. so here we are getting as a 1.16 value, right? So z is equal to 1.16. Let us check for 1.16 how much will be the psi value from this distribution, right? Here 1.16, you can see that it is 0.87, right here on the right hand side you can see. So yeah, 0.87, nothing but 87%, that is probable that a project can complete. And for 10 days, right, the second third one is for the 10 days. So for 10 days you can again see that t is equal to 10 days, so 10 minus 12 divided by 1.73, again you'll get that the 1 minus 1.16, that is nothing but what the 1 minus 0.877, that is 0.123. so that is, we can say that 12% probability, right? So you can see that you can find out the probability that a project can complete within 12 days, 14 days, and 10 days. So with this all the time estimations, the probability that project can complete in 12 days is 50. In 14 days, if we go for 14 days, obviously the probability can increase, right? It will 87%. But if we come to the lesser days, right, that is near to the 10 days, then obviously the probability is very less and it is 12% like that. Okay, so like this way you can solve these problems from the right CPM and Pert perspective, right? As far as the CPM Pert perspective point of view, right? If any queries in this, you may ask, right? The session is open for your questions and answers. Thank you for attending these sessions. If any query, you may ask, right?